Intermediate Algebra for Statistics, Using Factoring to Make Predictions with Quadratic Models, Part 2. Lesson Objectives: Use an equation of a quadratic model to make estimates and predictions. Model projectile motion and the area of rectangular objects. Lesson Objective: Example 3. A rectangular rug has an area of 80 square feet. If the length is 2 feet more than the width, find the dimensions of the rug. Solution: we will use the 4-step problem-solving method. Step number 1, we define each variable. X will be the width. This is the width. And the length is 2 more, so that's x plus 2. Step number 2, write an equation in one variable. So the formula for area of a rectangle is length times the width. From the problem we are given the area is 80, the width was x, and the length is x plus 2. We solve the equation for step number 3, so we distribute the x and we get 80 equals x squared plus 2x. Subtracting 80 to both sides, we have 0 equals x squared plus 2x minus 80. This is a trinomial that will factor. What two values multiplied will give me a negative 80, and at the same time add up to give me a positive 2. And because c is negative, the factors will have opposite signs. And it turns out if you take a negative 8, multiply it by a positive 10, you get a negative 80, and a negative 8 plus a positive 10 is a positive 2. Now, using the zero factor property, we take each of these binomials and set them equal to 0, and we have x is 8 or x is a negative 10. We cannot have a negative length or a negative width, so this solution in the terms of the problem don't make sense. So this is our final answer. X is equal to 8. So we check it. So the width is 8 and the length is 8 plus 2, which is 10. If we use our area formula, we see that 8 times 10 is 80. It checks. So the dimensions of the rug: a width of 8 feet and a length of 10 feet. Example 4. An object thrown or fired straight upward at an initial speed of v sub 0 feet per second will reach a height of h feet after t seconds, where h and t are related by the formula h equals negative 16t squared plus b sub o times t. Suppose a bullet is shot straight upward with an initial speed of 800 feet per second. Number 1, when does the bullet fall back to the ground? Number 2, when will the bullet reach a height of 6,400 feet? Number 3, what is the height of the bullet at 20 seconds? Number 4, what is the highest point that the bullet reaches? Solution: number 1, when does the bullet fall back to the ground? So we are asked to find the time when the height is 0. Because when the bullet falls back to the ground, the height of the bullet will be 0. So we are looking for what are the coordinates of A and what are the coordinates for E. So this is a simple little diagram illustrating the path of the bullet. So we substitute as 0 for our height, and then we solve for T. The first step, we want to factor out a negative 16. Don't forget, when you factor out a negative number, it will change the sign. So we have negative 16t times t minus 50. Now, from the zero factor property, either this expression is 0 or this expression is 0. So we set them equal to 0 and we solve, and we see t will equal 0 and t will equal 50. So at 0 seconds the height is 0, and at 50 seconds the height is 0. Number 2, when will the bullet reach a height of 6,400 feet? Again, we are asked to find the time when the height is 6,400 feet. So we plug in 6,400 for h, and then we will solve for t. Our first step is to subtract 6,400 to both sides. Now it's equal to 0. Next, we want to factor out a negative 16. and now we have 0 equals negative 16 times the trinomial t squared minus 50t plus 400. Next step, we want to get rid of the negative 16, so we divide this side by negative 16 and this side. Now we try to factor this trinomial. What two numbers multiply will give us 400, and at the same time will sum to be a negative 50. Well, because c is positive and b is negative, the two factors will have to be negative, and negative 40 times a negative 10 is a positive 400, and negative 40 plus a negative 10 is negative 50. So now we have 0 equals the binomial t minus 10 times the binomial t minus 40. The product of those two equals 0, so setting both binomials equal to 0, we have t is 10 and t is 40. So if we look at our little visual, at 10 seconds the height is at b, and at 40 seconds the height is the same, 6,400. So at 10 seconds the bullet is going up, reaches a height of 6,400 feet, and at 40 seconds the bullet is on its way down and it has a height of 6,400 feet. Number 3, what is the height of the bullet at 20 seconds? This time we are asked to find the height when we are given t, a time, 20 seconds. So using our formula, t is 20, so we substitute it in for t. Follow the order of operation. We have negative 16 times 20 squared, which is 400, plus 16,000. And adding those two, we have a height of 9,600 feet. So what does this mean? This means after 20 seconds, the height of the bullet is 9,600 feet. Number 4, what is the highest point the bullet reaches? So we are asked to find what is the maximum y value of this function. So if we go back to our illustration, we are trying to find what is the y value of point C. Now in future videos we will learn a formula that we can use to find the value of this maximum, and in some problems a minimum for a quadratic equation. But for now we will use the graphing calculator. So our first step is to type the equation in into y1. Using the table feature, we can see different values of time and the corresponding heights, and we know that the bullet will be in the air for about 50 seconds. So instead of counting by ones, let's count by something like 10 so we could see. So if we hit second and window, have the table start at 0, but this time instead of counting by ones, we'll count by tens. We have the following table of values. So it appears that the height is getting close to 10,000. This will help us determine the window settings for the graph. So if we press window, set the x-min to be a -1, the x-max to be 51, because we know the bullet will be in the air for about 50 seconds. We'll count by 5, the y-min -100, the y-max 10,000, and this time we'll count by 500. When we hit graph, we see this parabola. So to answer number 4, we are trying to determine what is this value that is a maximum value for the function. Hitting second and trace, we have calculate. We can go to number 4, maximum, and we can see the calculator is giving us a maximum value of 10,000 for y. This occurs when the time is 25. So in the terms of this problem, at 25 seconds the height of the bullet will reach a maximum height of 10,000 feet. Thanks for watching.